Welcome to qnawire.
So in this case, what we have are two 3-molar solutions of HCl and sodium hydroxide, and we're going to take 100 milliliters of each of them. We are told that when we mix them, we're going to find a change of temperature that we go from an initial value of 22 degrees Celsius to a final value equal to 40.7 degrees Celsius. That means that the delta T, which is equal to final temperature minus initial temperature, is going to be equal to 18.7 degrees Celsius. For the chemical reaction that we have in this case, what is being told for you in the problem is that you need to consider the reaction of H plus with OH minus that is going to produce a molecule of water. And the amounts that we're going to get in this case are equal to the concentrations, or the number of moles is equal to the concentration times the volume. In this case, both solutions have the same concentration, which is 3 molar, and the same volume, that is 100 milliliters, which is equal to 0.1 liters. That means that I'm going to have 0.3 mole of H plus and OH minus. So if we write down an ice table, which may have a different name in your language, what is going to happen is that we're going to generate exactly 0.3 mole, all of this is going to be in moles of water in the reaction. Another way to think about this is that we have 0.3 moles of reaction in this case. Now, we're told the change of temperature that occurred due to the reaction. So now what we need to consider is that in this reaction, what is being generated are 100 milliliters and 100 milliliters that are being mixed. So the total mass of water is going to be equal to 200 milliliters for this reaction, which is corresponding to 200 grams. The heat of the reaction is equal to the mass of water, the heat capacity of water, and the delta T that we experience. So in this case, we're going to have 200 grams of water. And here we're employing the volume of the solution, because that is the one that is going to be absorbing the heat from the reaction, times the heat capacity of water, which is 4.18 joules per gram degree Celsius, and the value for delta T, which in this case is 18.7 degrees Celsius. Let's verify that the units cancel out properly. Grams and grams, and we're going to find the heat in joules. So the result from this is equal to 15,633.2 joules. Or we can express it in terms of kilojoules, which is 15.63 kilojoules. Now, this comes from 0.3 moles of reaction. So the enthalpy, or the heat of the reaction, the delta H for the reaction, is going to be equal to 15.63 divided by 0.3 moles. Kilojoules divided by 0.3 moles, which gives us 52.1 kilojoules per mole. Now, since the reaction released energy, so the reaction released energy, that means that is exothermic. So we need to add a minus for the heat of the reaction. So the heat of the reaction is minus 52.1 kilojoules per mole. And that would be all. Thank you very much and have a good one. Just a clarification, this would be the delta H of the heat of neutralization for the reaction. And if you want to know how much heat was absorbed, just change the sign of the delta H for this reaction. That would be all, and have a good one.